Hello students, today we will start with very important topic for JEE Main, Advanced and NEET, that is chemical bond and molecular structure. This topic I will cover the entire topic which is based on a common syllabus of both JEE and NEET. Okay. So first of all, what is a bond? What do you mean by bond? Bond means a force of attraction, and any normal language you can apply this word bond, and according to the definition wise it is an attractive force which hold atoms, molecules, ions, that is called chemical species, together in a molecule so that the bond can form. So it is various types of particles which can attract with each other and form a bond. Okay, like you can in normal language you can say bond and chemical bond. These are the attractive force which exists between chemical species. So bond formation, why an atom or ion need to form bond? The main reason for this is bond, whenever it is formed, the main intention of bond formation is to gain stability. See, to gain stability, bond formation is there, to acquire minimum energy and to attain the noble gas or inert gas configuration so that it become highly stable. Okay. So these are the three reasons for bond formation, and bond formation is always an exothermic process. It is energy release process. So potential energy of the system decreases and stability increases. Whenever energy released, stability increases and energy decreases. Types of chemical bond. Bond are basically two types, either strong bond or weak bond. Strong bond having more energy, that is 200 kJ per mole approximately, or weak bond is somewhere around 4 to 20 kJ per mole. So this is a rough figure. These bonds are generally formed between atoms, so they are called interatomic bond, and these are intermolecular bond. Between molecules these bonds are formed. Okay. So there are four types of strong bond: covalent, ionic, coordinate and metallic. See, these are the four types which form between the atoms. Similarly, there are two types of weak bond: hydrogen bond or van der Waals forces of attraction. Okay, there is dipole-dipole interaction, ion dipole-dipole interaction. There are many imaginary forces, all are comes under van der Waals force of attraction. We will see each and every topic in detail, okay, during the course of the study, one by one. Valence electron part and Lewis symbol. Lewis symbol is nothing but number of valence electron which is equal to the Lewis symbol, which is equal to the number of dots in Lewis symbol. Okay, so see here, the valence electron is hydrogen only one, helium 2. So there is one dot, there is two dots, and in lithium one dot, one valence electron. This is the simple electronic configuration which you had studied in lower standard. 2 1, so one valence electron, one dot. Two valence electron here, so two dot. Three valence electron in case of boron, so three dot. In case of beryllium, two dots. In case of boron, three dots. Just symmetrically distributed. That's it. In carbons, four dots, so place at four places like this. Similarly, nitrogen 2, 5, 5 valence electron, so 2, 2, 4, 1, 5. Oxygen 6 valence electron, so 2, 2, 4, 2, 6. Fluorine 7 valence electron, so 2, 2, 4, 2, 6, 1, 7. And neon 8 valence electron. This way all the electron can easily distributed and symbolically represented using dot. So this is simple electron dot structure or Lewis symbol. Chemical bonding, octet rule. Atoms tend to gain, lose or share electron to achieve stable electronic configuration of 8 electrons, which is similar to nearest noble gas. So here, while bond formation, atom either gain electron, means they can gain electron from the other atom, or they may lose electron, or they may share its electron to form bond. So based on the various types of bond, if it is say sharing of electron, it is covalent bond. If it is lose or gain of electron, it is the ionic bond. Okay. So this way they can form 8 valence electron in its octet. 8 valence electron in its valence shell, that is called octet. So here some exception is there, which is near to helium, they possess duplet, that is 2 electron valence shell, not octet. So here in case of hydrogen, see the duplet 2 electron after sharing of electron. But in case of oxygen, see after using the dot symbol around the oxygen, I got 6 electron here, 6 electron here. So 2 electron each shared by one oxygen atom and form 2 bonds, so that both attain octet. So it is stable. So these are called bond pairs. In a bond, see covalent bonds are generally represented by hyphen. There are 2 electrons in this. Okay, we can say if this is the bond, 2 electrons are there. Simple. And these are non-bonding electron or lone pair electron. These are bonding electron, which is part of bond. Okay, these are bonding electron and these are non-bonding electron. So here one oxygen having 4 non-bonding electron, which is 2 pairs of electron. Another oxygen also 2 pairs of non-bonding electron. Chlorine 3 pairs of non-bonding electron. This way the octet rule or sharing of electron can be explained. Similarly, I can also explain the transfer of electrons. Say sodium chloride. So sodium will transfer one of its electron to chlorine, because as you know chlorine already having electrons, 7 electrons in its outermost shell. So sodium will transfer this. The cross one is the electron of sodium. So due to transfer of one electron, this acquire positive charge and this acquire negative charge. And you see it becomes 2,8 and this becomes 2,8,8. So they can form ionic bond very easily. So this way we can explain the gain of electron by chlorine, the lose of electron by sodium, sharing of electron in this species. To explain the octet rule, everywhere the electron number is 8 or it is 2 if it is nearer to helium. Okay. Thank you. Limitations of octet rule. It applies mainly to second period element, means only boron, carbon, nitrogen, oxygen, fluorine, some counted number, some fixed number of elements shows octet rule. Rest it is fails to explain stability of other molecule formation, like beyond third period in the periodic table. This rule shows expanded octet and it is failed to explain the stability of molecules which is having more than 8 electron in its valence shell after bond formation. See, such examples are phosphorus, sulfur, chlorine. They can form PF5, SF6, H2SO4, SO4 2 minus, Cl4 2 minus, PO4 3 minus. Hence, there are various molecules or ions which can show expanded or hypervalent octet, still they are stable. So, this rule failed to explain the stability of this type of molecule. Similarly, incomplete octet. Incomplete octet means some compounds they are having less than 8 electrons in its valence shell after bond formation, but still they are stable. Like say LiCl, BH3, AlCl. We will see the molecule structure here one by one, so that you can easily imagine how the number of electrons are less than 8 or more than 8. Okay. Say for example, in case of PF5, okay. So say P here, P having 5 bonds like this with fluorine, right? So each fluorine having 7 electron, this is, and phosphorus you know 5 electron is valence shell. So these are the 5 electrons and each fluorine having 7 electron, like this. right? So if you count the number of electron of fluorine and phosphorus surrounding to phosphorus, all the bond pair electron, it is 10 electron, right? 2 to 4 to 6 to 8 to 10, which is more than 8 electron. This is what? More than 8 electron. That's why this is called expanded octet. Similarly, another example I will explain, SF6, S here, and it forms 6 bonds with fluorine atom like this. Okay. Same number of electrons, 7, and its valence shell of fluorine. So sulfur having 6 electron and fluorine 7 electron. Then it share 1 electron each with 1 electron of sulfur. After sharing all these electrons, if you see the number of bonded electron, it is 12 electron, which is more than 8. So if it is more than 8, then it is expanded octet. So expanded octet means the number of electrons are more than 8. Incomplete octet means it is less than 8. So these are some examples. You can also show H2SO4. H2SO4 is also having more than 8 electron. There are many ions which shows more than 8 electrons. See, 1, 2, 3, 4, 5, 6. Here sharing of electron with other atoms. If you calculate the dots here, we get number of electron more than 8. 2 to 4 to 6 to 8 to 10 to 12. Total 12 electrons, which is expanded octet. More than 8 electron, that means expanded octet. This way we can explain PF5, SF6, H2SO4. Similarly, you can also explain PO4 3-, SO4 2-, POCl3. Many examples we can explain. This is expanded octet. Okay. Similarly, I will explain some examples of incomplete octet compounds. Okay. Say for example, LiCl. I will take example of lithium chloride. So lithium having only 1 electron in outermost shell, chlorine 1. So they will share its electron, and see, this is octet, but what about this? This is only 2 electron, which is less than 8 electron. And less than 8 electron means what? Incomplete octet. So this is also one of the limitations. Similarly, you can say BH3, which combine with another BH3 to form B2S6. So in BH3 or BCl3, AlCl3, BCl3, AlCl3, you can show such examples. Say this one. This is BCl3 example. I can write this in this way. Okay. So all this particular sharing of electron takes place between the central atom, and here only 6 electron present, 2 to 4 to 6. So it is incomplete octet. Less than 8 electron, that means incomplete octet. So some typical examples of this limitations of octet. Next limitation, fourth one, odd number of electron molecule or odd electron molecule. Octet rule fails to explain the stability of such molecule which contains odd number of electrons. See, for example, NO, nitric oxide. Here, if you see the structure, here 3 electron, here 4 electron, total 7, and in the bonded part, total 4 electrons are there. So if you count the number of electrons of both the atoms, say after sharing of this electron, it is 4 plus 3 7, and this is 8, total 15. So it is odd. Or this way you can see there is 1 here electron, so 3 means it is odd. Whatever you add, it is odd plus even, it is always odd. Similarly, in this nitrogen dioxide, the number of electron in the central nitrogen atom, see 1, 2, 3 same way, this is the coordinate bond. Here there are 2 electrons present in this bond. In the coordinate bond 2 electrons are present. So here this particular species, you see the count the electron of this total. So 8 electron satisfied by both the oxygen atom, and this is 7 electrons. So total 23, which is again odd number. The 3 electron here odd number. This also you can easily identify. Similarly ClO2, 3 electron here, and there 4 cell, total 8 and 7. Total 17 electron of oxygen. This way also total electron you can calculate, or just by observing this number you can calculate. So all these 3 species, they are stable, they don't follow the octet rule, and they possess odd number of electrons. Similarly, octet rule fails to explain the geometry, the reactivity, the magnetic character of molecules. So there are 5 limitations of octet rule which are enlisted in this particular topic. Thank you.